Another cool thing is the Drizzly delivery person is doing like a Turing style thing. It's not Turing, but it's like Turing. And yeah, like
you deliver it again too? Next time?
Yeah, so he's going to try to come on. He told me should. Like even okay, get started. I'll start whenever you get back.
Oh, don't worry about waiting for me. The stream's all going, so yeah.
Hello? That's loud. Sorry about that. Let's go ahead and get this kicked off. Welcome everybody. React Denver. Woo! Yeah. Woos. Woos all around. More woos. Real quick before we start, I'd like to go ahead and say hi to my wife and daughter because they're totally creeping on me right now on the webcam. Everybody say hi to Carolyn and Casey. Hi, Carolyn. Hi, Casey. That'll probably embarrass her. I'll pay for that later. Yeah, thank you so much for coming. I think what I'd like to start off with is just saying, oh, sorry about that. Let me just, AV issue, drink.
Turn it up.
Yeah, I know. Cool. So, first of all, I'd like to thank everybody for coming. I think it's really great, and I think we've seen like a really amazing increase in attendance the last few meetups. And I really would attribute that to our awesome speakers. They bring in a lot of really good content and a lot of really interesting ideas. And I'm really grateful for the folks who come here with the great ideas. I'm really grateful for all of you for coming today. I think it's great that you all come here. You spend 2 to 3 hours listening to people talk about technology. That to me means that you're super passionate about what you do, or you're super passionate about breaking into the industry. And yeah, so I just wanted to say thanks. Cool. So let's get some of the other stuff out of the way. If you didn't notice, there's pizza. There's also drinks. If you get thirsty, please just get up and grab a drink. And then bathrooms. There's a hall of bathrooms. Yeah. So there's a hall of bathrooms located straight behind us. There's also a women's bathroom right here. And then if you travel through the maze, you will eventually find the men's bathroom. I promise you'll find it if you look for it. But I mean, there's like 5 of them there, so we should be good. Another thing to note is I really would like to thank our sponsors, Turing, obviously, for hosting us. They've been our host for like the past 3 or 4 months. It's a great space. We really appreciate it. Also, a shout out to Granicus and CA, which is actually where I work. They paid for the pizza and the drinks and all the stuff that makes it worthwhile, at least the 30 minutes worthwhile. It helps everybody sit here and remain calm. So you may have noticed that there's a board behind me that says who is hiring. There's some contact information, but we'd like to try to set aside some time for folks to speak up. So if you are hiring, please go ahead and feel free to just stand up and announce who you are, what company you're with, and how to contact you.
Hi, sorry you guys have to break your neck to turn around here. My name's Corrine Ross. I'm with Ross Search Partners. My partners in the corner here, Andy Ross. Thank you for having us. And we are hiring. We need React talent. We have 2 clients that have been on Angular in the past that are now shifting all of their new work to React. One is in Golden, full-time position. The second is in Louisville. So what they're looking for on these next hires for their full-time positions is a bit more mid to senior experience. So to them, what that means is at least 5 years on the job, you know, maybe ideally 1 to 2 years React, something like that. So please reach out to me if you're interested in learning more about that, or just in general, if you're in the job market and want to, you know, just do some networking. Please give me a shout. My email's there, or you'll see me on the Meetup or LinkedIn. So thank you.
Thanks, Corinne.
Hi, I'm Shermeen. I am the first one on the board. I work for a company called Klein, which is a private equity firm. So we have companies across the nation, but here in Denver specifically is Crown Peak and eFolder. And currently for Crown Peak, we have 2 senior developer positions open. One's .NET and one's Java, and someone who has an interest in Scala. And then also junior developer and junior QA. So if you have interest in any of those, or would just like to stay in touch, email me, and I'd love to set up a chat.
Thank you. Anybody else?
Hi, my name's Josh. I work with a company called Envision there at the bottom. I look for people to come help me kill an Angular 1X app. So we're in the video surveillance space. I'm trying to build a React team, so I'm looking for people 3 to 5 years plus on the job, some component-based application experience. I have on there a senior React engineer and a senior full-stack engineer. We have a fair amount of Scala, we have Node, we're mostly on Express. So come chat with me if you have any interest, or my work email is right there, so just drop me a note.
Thanks. Does anybody else have? Yeah, go ahead.
Yeah, I work with Guild Education. We're just down the street. We do education as a benefit, and we're looking for a senior full-stack engineer and data folks. So come chat with me if you're interested.
All right. Is anybody else hiring? The rest of Denver is not hiring. It's the only 4 people hiring. Right. Okay, we got a couple of really awesome talks tonight. I think my own interpretation of them is that they stem from a place of user empathy. One being offline first applications, and I was chatting with Nick a bit about it, and it sounds like it sounds really interesting. So you can see here how to contact him on Denver Devs if you have any questions for him later. Our second talk is going to be from Will Klein on end-to-end testing. And I think, again, it comes from a place of user empathy, but also being able to go home at 4 o'clock and know that your application isn't going to break at 8 p.m. That's the nice thing about end-to-end testing. Anywho, I'm going to go ahead and hand it over to Nick, and why don't we give him a round of applause.
Need like some hold music for you guys while I get this all going. Check, check, check. All right. All right. So yeah, I'm going to talk about offline first applications, and we're going to kind of take like a high-level overview of all this stuff because the state of the union for offline applications right now is a bit of a mess. There's some things that are really awesome and work really well and you should implement today. And there's some things that aren't quite there yet and we need a little open source support, and hopefully some people here will be excited enough to jump in and fix some of that stuff. If you're interested, you can go ahead and download my slides here and follow along, and if you have any questions or anything like that. But that's nickstevens.com/offline-first-reactjs-denver.pdf. So basically, a little bit about me real quick. I do UI development and design, and right now I'm currently at Off-Grid Electric, heading up their user experience department. And I also used to teach at BDW, their front-end classes. I'm an alum from there as well. A lot of the stuff I'm going to talk about is sort of inspired by a couple design methodologies, human-centered design, as well as the sprint method by Google Ventures. I'm not going to go into the design aspects too much in this talk, because this is mostly a dev talk, but if you're curious about these things, I encourage you to check them out, because they're great methodologies for building applications that, as Will mentioned, are based in empathy for your users. And that's really where this offline first concept came from. So I want to talk a little bit about what offline first actually means. So basically this means building an application to function without an internet connection at all. And then kind of adding on functionality and features as internet becomes available. You might have heard the term mobile first. This was a term that was really popular a few years ago as responsive design became popular. And it's still popular, and it's still how I would recommend everyone build their web apps, is mobile first. Well, there's a lot of similarity between mobile first and offline first. In both cases, you're sort of building for the most resource-constrained environment first, and then you add on functionality as you go. And so in the case of mobile first, you're building for a small mobile screen, and as you get more screen real estate, you can add in additional content or features and increased features too related to like processing power and stuff as you get on a desktop. Offline first is kind of like that. We start by building for a completely offline scenario. Excuse me, and in doing so, we actually make the experience better for people who are on 2G connections, 3G connections, or even full broadband connections, even like a Google Fiber connection. When we build and we use empathy to build for this user in an offline first manner, we make it better for all of our applications, or all of our users, sorry. I want to talk about a couple of use cases that you might run into that are really important for offline. We've all been on the airplane just twiddling our thumbs because we don't have access to Wi-Fi, or because we don't want to pay the like $15, $20, $30 that it costs to get Wi-Fi on an airplane. So this is a pretty popular application for offline. Even if you do pay for the Wi-Fi on an airplane, it usually blows pretty bad. Like, it's almost like a 3G connection on a phone, and even sometimes that's better than you normally get. So this is a great scenario for offline. Also, if you've ever driven across country, I drove the loneliest highway in America last year, and it's pretty crazy. There's tons of places in America that still don't have access to internet, that still have like roads and highways and things like that going through them. So it's not abnormal if you're, a trucker or any kind of driving business to be going through one of these areas and not have access to an application. And maybe there's something that you'd really need. If there's like some kind of application that shows you how to fix a tire or something like that, that could be an emergency situation where you might want to have those kinds of resources available on your mobile phone, not necessarily in an app form, but in a web app form. Subways are really popular. Not all of these have internet connections at this time. It kind of depends on your provider. But I used to live in DC, and I'd take the metro to work every day, and I spent an hour there and an hour going back. So I was on the metro for like 2 hours a day, and I had no internet connection for most of that time. And so before I'd go run down into the tunnel, I would download a whole bunch of RSS feeds. Which I don't think anyone really like uses RSS anymore, but like I was grabbing all of these for like offline use, and this was before anyone was even talking about making like blogs or websites offline. But you could do it with RSS by grabbing all that data, and it made like I basically learned dev like looking at code examples through RSS and stuff on the subway there. This one's really popular in Colorado. Whenever you're out hiking a 14er, most of the time you're not going to have access to internet unless you own like a satellite phone or something like that. And if you do, again, satellite phones are super slow if you've ever used one. There's also emergency scenarios here. If you wanted to carry like a first aid app or something on your phone, offline can be really useful in this kind of scenario, having all that data pulled down and cached on your device. So you might be noticing a theme throughout all of these, and that's travel. If you work in an industry where your users are traveling a lot, you should probably pay a lot of attention to offline. This can be a huge competitive advantage for a company to be able to have their application working offline when everyone else is in the industry might not be. There's not a lot of people who are doing offline applications when it comes to web apps right now. If you're the one that can grab that person's time while they're sitting on an airplane for 2 hours, that's 2 hours you get with your user that your competitor doesn't. So big plus for a company that's going this route. So I work for a company that we do solar panels in Africa, or solar setups, I should say, in Africa. It's basically like panel on the roof. We run a few lights in the house, usually a television or a radio and phone charging and things like that. So this is mostly for residential areas or residential situations. And we're running out in the field to sell all of these systems. We actually employ a pretty large sales force. And they're going out in the field and they're literally like walking out of cell phone range. It just drops off really quickly sometimes in rural Africa. And so they need to have an application that functions offline if they're going to make sales while they're in these more rural villages. It'd be a real pain to have to just like sit there and write everything down and then get back to internet connection and then like type everything into the app. We can easily just take all the information right now and wait till the user has access to internet again. Even if you're in the city sometimes in Africa, the connections there can be really, really spotty. So this is our workshop in Arusha, Tanzania. And basically these guys are going through and they're scanning boxes and they're troubleshooting them and things like this. And unfortunately, the application that we have for them right now is not built offline first. And so whenever the internet goes down, you have 10 to 15 people in this office that can't work at all. They're basically stuck there doing nothing until the internet comes back up. And sometimes that's a couple hours. So it can be a huge kill to your productivity as a team if you don't have access to that. We also have a call center who, when the internet goes down, they don't have access to customer data. So people are calling in because our call setup is actually still on landlines. But they're calling in and they can't access customer data. And that's a huge problem to your customers when you can't help them for a period of time. So a whole lot of issues show up in Africa, and this is only going to get bigger as you look at smartphone penetration in Africa. Back in 2010, there wasn't very much, but by 2020 we're looking at 57% smartphone penetration, almost as much as the world, as the global standard for smartphones. So this is a lot of people who are going to be getting smartphones and getting access to the internet for the first time. And unfortunately, they're not going to have very good data connections to start off with. Even by 2020, we're looking at almost 50% of smartphone connections in Africa still being on 2G. So the more we can build from offline, the more we open ourselves up to these new markets. And right now, we're looking at about 494 million people being added to the smartphone market, to the internet for the first time by 2020. That is a huge market. And if you're in a company that could potentially sell to someone in a developing country throughout Africa, that's a 500 million person market that you didn't have access to before. And if you can build offline, you're going to have a huge competitive advantage over your competitors. So, all right. Hopefully I've convinced you by now. Let's actually talk about how to do offline first, especially since this is about development. So there's a lot of areas we have to focus in on for building offline. And so we kind of have a few goals. The first is we want to notify the user when they're offline. We also want to be able to make sure that we serve the app when we're offline. And then we also need to make sure that we can give them data when they're offline. So in this case, we'd be giving them like previous data from earlier connections, earlier queries. And then if we have a query that's fired in our app while the user's offline, we want to make sure that we're actually able to retry that query when we come online again. So we need sort of some scenarios for failure built in there and taking care of those. And then if we're making a change, like an update to a post or something like that, some kind of patch or put or post kind of thing, we want to make sure we can retry failed mutations so that we're staying in sync between client and server. So we have a few solutions we can do for this. When we're talking about notifying the user about whether they're online or offline, we can actually manage that state, the online, offline state in our application. I'll talk in a second about how we might do that. If we want to serve the app when we're offline, we can do some asset caching, and we're going to talk about service workers in just a second. And then for serving data when offline, we want a persistent data cache that even on page reloads, the data that we've fetched previously, we still have available to our app and can serve them data. So even if it's not the most up to date, at least we're giving them something. And then query retries for whenever we have queries that failed. And then finally, this concept of queues, which I'll talk about, where whenever we're making some sort of change to an object, we'll queue up those changes and send them off whenever we come online. So to start off, online, offline state. And if anybody has any questions as we're going through this, feel free to like stop me and ask about this, because there's a lot of topics within offline and it can get a little confusing. So the problem that we're talking about here is that users may have no idea whether they're on or offline, and we want to set their expectations. You may have seen in like Instagram or something like that, they'll let you know when you're online or offline. So if your pictures don't show up immediately online, you're not surprised. So in order to let the user know, we want to inform them when they go offline, provide some sort of UI, but also be able to actually track that connection and let them know when they come back online. And the way we're going to do this is by tracking the state of the application's connection to the network server. Now, the most popular way to do this right now is with navigator.online. This is something that's built into browsers. It's got pretty good browser support right now. And it's basically a Boolean. You can check on this Boolean to see if you're online or offline. And there's also some event listeners that you can use to trigger different methods depending on when you go online and when you come offline. There's one big problem with this, though. And that's that in Chrome or Safari, if the browser is not able to connect to a local area network or router, it's offline. You would expect that to be the case. The other problem, though, is that in all other conditions, this is actually still true. You're still saying, navigator.online will still say you're true in all other conditions. Some of these conditions include any drop in the network between your wireless router and your server. And that's a whole lot of areas that aren't accounted for by navigator.online. So you could still be connected to your wireless network, but have the connection drop somewhere between your wireless network and your server, whether it be something goes down at a data center or something like that, or just your provider is, your ISP is messed up. And navigator.online would still tell you that you're online. So we have some new solutions for this, and really the question that we're trying to answer in these new solutions isn't something like navigator.online, it's can we reach the server? That's the ultimate question for offline use. And the way we can really manage this is by checking in on network errors, timeouts, 500 errors, things like this. So I actually have developed a little bit of open source that I released called Redux Offline Status. And basically, this is some middleware to track whether you are online or offline via Redux. So the first thing that you have to do is you have to manually look for a network error or something like that. And then you fire an offline event. From there, this middleware picks up, and it's actually going to continually ping either your server or a server like Google or something and download like a favicon to see if there's a connection. And it's continually pinging. And once it pings and gets a successful connection, it'll fire an online event, and then your whole offline or your whole online queues and everything that you have set up will start to fire at that point. So this is a much safer way of figuring out whether you're online or offline. This is a little bit code about how it works. So this is network error method inside of here. That's a method I created that I haven't quite released yet, so that one's kind of hidden right now. But basically the question is, do we have any kind of network error? If so, dispatch this offline method. And then from there, you don't have to do anything else. The Redux offline status is going to pick up and handle all of your actions to take you online from there. All you have to do is in your component, do a check for is offline, and you can fire some sort of, or show some sort of network error warning or something like that if you're offline, and then switch it up otherwise. If you were here last month, you saw Chris Boland gave a talk on his package React Detect Offline. It's a pretty cool way to show whether you're online or offline. You can basically render different content with these online and offline components. Chris and I have been talking though, and there's one big issue with this library is that it uses navigator.online right now. So hopefully soon we're going to be able to open this up to some other options like using Redux Offline Status, and you'll be able to leverage this really awesome interface for handling online and offline. So great way to manage your UI there. Okay, any questions on sort of the offline online status before we jump to the next section?
I have a cool question, that's okay. If you're using that polling method with your server, do you think that could get problematic if you have a lot of people using it, and you have to keep track of all these polling, these pings that are just really status indicators and they're not actually like real traffic?
Well, it's only going to send one request because most of those requests are going to fail if you're offline. So it's only one request that's going to hit, and it's only when the user is offline and they return offline for the first time. So it's only that first request that's going to actually hit the server when they finally do come online. So I think that should manage most of the scenarios without it being too crazy. But does that answer your question?
So you only send one request the entire time?
So what's happening is you've got this poll set up, and while you're offline, the poll fails, and so the request never actually hits your server. Then when you finally become offline, whether it's through your Wi-Fi router is suddenly fixed or your mobile network carrier is suddenly fixed, then you have one request that goes to the server, and it comes back and it says, okay, that was successful. Now you're online, fire the online event in Redux, and everything else can sort of turn online. And at that point, you might have multiple requests going out at a time, queued requests and things like that. And that, I could see a scenario where you might want to be prepared for that if you had if someone had 100 requests queued or something like that. I don't know how often that's going to happen, but that could certainly happen because of all those queued requests. But the actual poll only hits the server one time. And also, it's rare that a whole bunch of your users are going to be offline at a given time if you're a large app and your users are spread throughout the globe. But maybe if you were a geographically focused type app and you had a bunch of people lose internet and then they all of a sudden come back online, that could be a big issue, certainly. So,
say one of the examples you gave earlier was a call center, and I could see easily you've got 30 plus users in the call center. If the entire call center lost access, then you'd have that volume when the network for the whole call center comes back online, you'd have 30 users that have got queued up.
totally. Yeah, that could be an issue.
Also, if the outage is actually coming from your end, like if I work on really small, simple systems, so I guess this kind of scenario wouldn't happen, but during a deployment, right, I take the app down for just a minute or two, something like that would be a single, it would be like a whole bunch of, also cause a whole bunch of users to end up in the queue.
Certainly. Yeah, I think there's probably good ways to solve these. I don't know them yet. We're still pretty early on in the offline world, and I haven't experienced any of these issues yet, but as these ideas scale, we're probably going to have to find some good solutions for this. So thanks for pointing that out.
Is the first ping triggered just by a failed HTTP request?
It's not just any failed HTTP request. It would be a network failure. And there's basically each browser has its own way of giving a network error request, a network request error. And that's kind of what I'm working on with that method I was talking in there, is kind of detecting those in each browser. If you would have a 404 error or something like that, that wouldn't necessarily trigger this. But the triggering is actually all in your hands with Redux offline status. So you decide when you want to shoot that error. I wouldn't recommend it with something like a 400 error or something. Yeah.
So one last option on that polling thing. So we have at least 15,000 clients polling at any given second, and the SSL handshake is the most expensive part. So what we actually do is throw a basically Optimum endpoint outside of our SSL, so that way the app can check and go, are we online without doing the handshake every single time? Because you may see that your proxies are online and you're paying for the SSL handshake, but your app server is down, right? So you're causing your own load there. So you can put your online status outside of SSL.
Yeah, you can also ping Google if you want to. You don't have to actually take that hit, but is offline is the package that we use in Redux offline status, and actually by default it's like looking for a favicon at Google instead of your own server, and then you can plug in your own server if you want. So, yeah.
Are there any APIs to detect how long the request took to round trip inside the app? I know obviously you can go to Chrome Developer Tools and see how long it took, but is there an API within the JavaScript environment itself to check what latencies are? I mean, obviously if you're having a round trip of 5 seconds or something, I mean, you might as well be offline, right? But technically the connection's still there. Are there any APIs to?
Yeah, so you're basically talking about timeout errors and things like that?
Not necessarily even a timeout. The request might be succeeding, but the request takes so long, right, that round trip. I mean, you talk about rural Africa, right? Part of the problem is that they're making requests to a northern North American server, right? I mean, plus whatever latencies from the slow connection, unreliable, you know, I mean, all the stuff that can go wrong in wireless. Are there ways to kind of detect that a connection is degraded enough that it's worth working offline, even though technically you do have a connection?
Right now, I'm not sure, but I do know that there's something coming out pretty soon that I actually have later on in the presentation that I just kind of cover real quick. But there's a new spec that's coming out. I think it's network information or something like that. I don't know. It's in a later slide, but I'll mention that when we get there as a potential solution, I think, to what you're talking about, where you can basically tell the difference between like a 2G connection and a 3G connection and respond in your application as a result. That's totally a spec right now, though. It's not implemented in any browser, but when it is, that's going to be pretty sweet for what I think you're talking about.
Just wanted, I know you're trying to fun. I just want to let you know though, you could, if you wanted to, you could look at something like a subscription. That's something that they do with Apollo and GraphQL, and it basically opens a WebSocket connection. It might, I don't know if it's going to be more efficient or whatever, but that it might just be instant to know that the WebSocket connection's closed, as opposed to having to pull every couple seconds or something.
Yeah, I haven't done anything with WebSockets yet, but I really want to. So
yeah, it's actually it's a subscription, but it uses WebSockets. Yeah.
Cool. Okay, so jumping on, I want to talk about asset caching with service workers. So some of you may have seen like this little offline dinosaur game. If you've ever like gone offline in Chrome, it gives you a little like game to play, which is kind of nice, but it also really just sucks to be like offline. So really, you never want to actually be able to like play this game because it'd be much better to see the application itself. So the problem that we're really facing here is that users can't access the application when they're offline. And our goal here is that we always want to serve the user a working site. And the way we're going to do that is to serve the user a cached version of the application, so an older version of the application from the last request that you made. And the way we do this is with service workers. So a service worker is basically kind of like a proxy server that sits between web applications and either the browser or the network. And enables you to create great offline experiences because it's basically intercepting all your network requests and sort of reacting to those. So it's great for taking like your HTML, CSS, JavaScript files and caching them locally and then serving those up as an alternate to going all the way to the server and grabbing that request. There's a really awesome library for this. You could go and like build service workers from scratch, and if you're not using Webpack, that may be a great way to go. But if you're already using Webpack, as many of us probably are, you can get a service worker going and cache all of your Webpack assets with just a few lines of code. This offline plugin is really, really cool. You basically throw it into your plugins, and you can actually pass a configuration into offline plugins. So if you want to add some custom methods to your service worker, you can do that. You can also cache additional assets outside of your Webpack. So if you've got a CDN somewhere with a whole bunch of images or something like that, you can throw those into the configuration and cache all of those. It's really cool, really powerful plugin. It's super easy to use. And then after you've configured in Webpack, you just need to kind of throw it into your runtime. It's just one method inside of your runtime. And you've got all your service worker handling right there. It'll totally pull the service worker down, activate it, install all your HTML, CSS, JavaScript files and all that. It'll handle all the updating of those when they change. It's really easy to do. And this is something that's great not only for offline, but like for just your users in general. Adi Osmani was doing some testing around this, and he found like he could get time to first interaction. I don't remember if it was page load or time to first interaction, around like 700 milliseconds as a result of a service worker because all of it was cached locally. So these are awesome. If you get one thing from this talk tonight, it's go back to your Webpack and install offline plugin like right now. So. Browser support does kind of suck with service workers right now. Chrome is like the main one that has it, but the cool thing is that it gracefully fails in all of these environments, so you don't need to worry about it too much. I've heard that Safari, that service workers are in tech preview right now, so it should be coming pretty soon. You heard that as well? Yeah. So I don't know about Edge. Do you know Edge or Internet Explorer? Yeah. Yeah, not coming. So. Cool. Hopefully someday, but for now we'll enjoy it in Chrome. Fortunately, our users are actually like almost all on Chrome, which I know you're all jealous of right now, but we give all of our laptops and devices out, so we make sure they're loaded up with Chrome before they get them. Okay, so the next thing I want to talk about is the persistent data cache. So we talked about sort of caching assets. Now we're going to talk about caching data. And you can actually do some of this stuff, some of the data caching with service workers. I haven't seen like a really great implementation of it. I think actually like Apollo would be able to do a ton with this if they decide to go down this route at some point in the future. But for right now, we're doing some cool stuff anyways. So the problem here is that queries for data fail when you're offline. But you still want to be able to show some sort of content or data in your application, even if a request hasn't returned, or even if that request is never going to return from the server. And the way we do this is by serving a cached version of the data from the last query. So there's a really awesome library that you can use for this called Redux Persist. And basically what Redux Persist is doing is it's working with either local storage or IndexedDB or something like that. It actually uses local forage on the back end, and so you can kind of hook up your own connection to whatever local storage device you want to use. And it basically is watching your Redux store, and every time there's a change made to your Redux store, it automatically saves that to your local storage or whatever. And the great thing about this is it's pretty easy to implement as well, kind of like offline plugin. You're really looking at a couple of lines of code. So the persist store, once you've created your store and everything, that persist store will basically hook into your store and make sure every time a change is made, it gets saved to local storage or something. And then you see the auto hydrate function there, auto rehydrate. Basically, it's not enough to just save it to the local storage. When you actually have a reload of your page, you want to make sure you can grab all that data. And so the auto rehydrate method inside of the enhancer on Redux is basically going to say every time the page is reloaded, every time your application starts again, go grab all this data from the local storage, load up your Redux store, and bam, you've got all your data in your Redux store like you were never even offline, or like the application never even was reloaded. So pretty cool way to get quick data results from your Redux store.
They just came out with a brand new API and it's even better.
Yeah, I saw that. V5 is out. That's V4. I haven't had a chance to play around with it yet.
Way
Nice. So you can actually use Redux Persist with Apollo 1.0, and it's pretty similar setup. You're basically just, whenever you set up your client, you're going to grab the client.reducer and client.middleware methods on your client and plug those into your Redux store. So really easy to get this going with Apollo as well. And then whenever you reload your Apollo application, you don't actually have to make any GraphQL requests to actually be able to serve data to the user. Unfortunately, you can't do this with Apollo 2.0. There is no more Redux in Apollo 2.0. They've actually implemented their own cache. And the solution here, I'm going to talk a little bit later about where I think Apollo 2.0 is going. I think it's actually a really cool place. But right now, we're kind of in a little bit of a lull because the solutions haven't quite been developed yet. A quick note, though, about how Apollo caches. I know there's probably a lot of people in here who know way more about Apollo or GraphQL than I do, but my understanding of Apollo is this, that if you make a query in Apollo, it will cache that query, but if you make a query for the same data, but it's a different query, it can't actually grab the cache version of that data. So it can only grab the exact query that's made before. And basically, I think it'll make more sense if I say it with like an actual example. So if you've got like a list of items and you query that with Apollo, and you execute that while online, you can have that list of items cached in your Apollo setup. But if you were to go offline and you reloaded items list, that would be able to show up. You'd be able to grab that. But if you were to actually like go to a specific item on your items list and you were to try to query that via Apollo, even though you've already pulled down all of that data, and even though it's in your cache, Apollo isn't smart enough to go and grab just that one item from that larger query that you already made. Do you disagree?
Well, that is true initially. but if you give, I forgot what the name of the term is, but Apollo uses a normalized cache, and you can give everything an ID, and you do that so everything works as a graph system, and there's nodes, right? So you can get to something in a different way. So it uses different edges to get to that node. And if you give it an ID, it knows that's the same exact node for each path. So you do that, you can get it.
Gotcha.
And just one, sorry, I don't mean to keep on
No,
telling you
please.
things, but Apollo 2.0, you can use Redux, you just get to it in a different way.
Really?
But it's still there.
I
They're
haven't
doing
seen
something.
that.
They're doing something called Hermes cache, and that's using TypeScript or something, and it's some internal thing that doesn't use Redux. But you can still use it. It's just a different. You get to it differently. But
Okay.
you can still do everything you did do with Apollo 1 with Apollo 2.
I'm gonna pick your brain about that afterwards.
Just to let you know.
Yeah.
So I don't mean to.
Well,
interrupt you, but-
that makes me excited because I actually want to see that happen. Okay, jumping on to query retries. So the issue that we have here is we've got a query that's failed because we've been offline, and so our recent data is not fetched. But when we return online, we want to make sure that we can still get that information. And basically, unless you've set up some sort of error handling or something like that, a request isn't just automatically going to go and retry itself once you go online. And what we're talking about here is actually during the same runtime. I'm going to talk about how we might handle this for other operations when you have a page reload or something like that. But the way we're going to handle this is we're going to set up retry listeners in our error handling to fetch the most recent data. So we've been working on some open source software over at OffGrid that we're calling Offline Request Saga. And I don't know if any of you all have used Redux Saga. I think it's pretty awesome. It makes handling asynchronous operations way easier. It's kind of like async await, but it uses generators instead, which has a little more functionality. I don't know exactly what that functionality is, but they're pretty awesome. And my experience using Redux Saga has been really beautiful. We're also relying upon the Redux offline status project I talked about earlier, and then Redux persist as well. But basically, the way this works is you've got this method called getRequest, and this method takes a promise function that basically, this promise function should handle your entire request to the server. So it'll make the fetch and everything. And then the second parameter is an action, which if you're using an implementation like takeLatest in Redux Saga, takeLatest is basically saying for every time get items is called, you're going to take the latest version of that and use that as the action to plug into get request. And so every time get items is called, the latest version is going to get plugged into get request. And then we are passing in this get items promise function, so that's the one that makes our fetch request or whatever it may be. And that gets passed in to get request at that time. And so it's basically saying inside of get request, okay, make this request. Oh, I'm offline. Okay, don't make the request, hold it, wait to be online, and then once you're online, it'll make that request again. And that's the beauty of Redux Saga, is you can handle all of this asynchronous operations in just a few lines of code. And this is tied into Redux as well, so it's looking at that offline-online state from Redux offline status to basically determine when it will retry this method. There's also a package called Redux Offline, and one of the cool things about Redux Offline is it has built into it Redux Persist, which I talked about before this. And so when you set up Redux Offline, you actually get Redux Persist kind of for free in there. One bummer about Redux Offline, though, is that it's using navigator.online to check for everything. You can plug in your own function or your own method to check for online-offline status, so you'd be able to kind of configure it, but by default, it's using navigator.online. And the cool thing about Redux Offline is you really don't have to do anything to start getting query retries. It's pretty easy. Now, I want to note a couple caveats, though, in Redux Offline. This is great, a great project, but the original owner kind of fell off the face of the earth for like several months, and a whole bunch of bugs started kind of showing up over that time. And finally, a good team of contributors came together, forked it, and they finally got him to transfer ownership. So Redux Offline, just in like the last week, got a whole bunch of bug fixes and has been sort of relaunched. But there's there's been this transition and it hasn't completely sort of settled yet. So at this time, using it, you're in a little bit of a precarious scenario because some of the things that rely on Redux Offline might be relying on the older version, which is a little bit buggy. And like, for instance, I use Redux DevTools a whole lot when I'm developing. You can't actually use it with Redux Offline, or at least with the older version. They should have a bug out in the new version, but not in the old version. So that was kind of like a killer for me. And then also, it was having troubles persisting the queue whenever you'd have like a page reload. So this is a cool library. I would say proceed with caution right now. It could be that like a week from now, all of these are completely solved and everything's beautiful again. But again, kind of base it on what your needs are at this current time. Implementing Redux Offline is pretty simple, kind of like Redux Persist. You're basically just passing something in, this offline method, into your store setup. And then when you are calling an action, kind of like GET request, you have like this get items function, which is going to be a promise. You're going to pass that into your action in sort of this meta field as the effect parameter on an offline object. And basically, that's going to handle all the query retries. So it's going to be looking at its own state for offline and online and say, okay, we're offline right now. We're not going to execute this effect yet. Okay, we've just gone online. Now we can actually execute the get items promise function effect. And then you also pass in a commit action. And this is basically the action that gets fired when get items promise function completes and the request is complete from the server. And that'll get fired with all of your data from the server as well. And so you can handle that in all of your reducers. Okay, with Apollo, at least with the 1.0 version, there's something cool called Apollo Offline. And this is actually based on Redux Offline. So, or not based on it, but it is, Redux Offline is a dependency for it. And this is one of the issues where I was like, I'm not, tread carefully at this point because it's been a little buggy. And last I heard, they were relying on the older version of Redux, which had some bugs in it. But how it works in Apollo Offline is you have this idea of an optimistic fetch. And basically what happens is it first goes to your cache and says, can we complete this query through your cache? And if so, it'll immediately return the query from the cache. And then at the same time, it'll also go out and see if there's a connection to the internet. And if so, it'll grab the data from the server and update the cache. If not, it'll wait. It knows to basically wait until the connection comes back, and then it'll make the request to the server and finally update the cache with your newer data. So it's kind of a cool fallback that Apollo Offline has to be able to check the server. I'm kind of surprised that this isn't like built into Apollo 1.0 sort of off the bat, but I don't know, I didn't make it so. So if you are building a wrapper for your components and using the GraphQL method in Apollo, this is what it would look like with Apollo Offline to get the optimistic fetch feature. You're basically running network only, which is kind of weird because it's not really network only because you are hitting the cache. But you pass in this sort of offline true flag, and that's how it will know to do the query retries and everything with Apollo Offline. Okay, queues. So this is the last sort of big concept within offline mode that I'm going to talk about today. But a queue, basically the problem is when you've got a post, a patch, or a put, or any kind of mutation that fails, your client is then out of sync with your server. And the goal that we want to have is we want to ensure that any post, patch, put, or mutation request is executed as soon as the application returns online, even if that application has been reloaded. We want to persist this so that we can make sure the client and the server are then in sync. And client, it can be a real pain when these things get out of sync, so we don't want to have that happen. So the way we manage this is with a persistent queue with retry logic. So what that basically means is we're going to take all of those requests, throw them in a queue, save this queue to Redux or some other local storage system, and then whenever the offline comes, whenever we come online again, we're going to go ahead and execute that queue and execute all of the items in that queue. So in offline request saga, the stuff that we've been working on, you're basically managing most of this in a custom action. So if we've got that same update item, or sorry, not the same, but we were talking about get items before. Now we're going to talk about updating an item. The requirements for offline request saga are basically you need to have an ID in there. You need to have your URL that you actually want to hit because there's going to be a fetch request that's going to manage this. And then what kind of method you're going to use, and then all of the payload, all the data that you want to send with that request. You can, if you like, you can send more data in this request, like item and whatever your payload data is. And that can be useful for error handling, but it's not actually used by offline request saga. And then finally, you've got this queued true flag that you would use. So another method that's really popular in Redux Saga is take every. And basically what happens is every time the update item function, update item action is called, it's going to call queue request method from offline request saga and pass along this action that you've created. And as long as you've got all of those items in your action, it'll be able to successfully queue that item. And it'll save that queue to Redux, which will then get persisted through Redux persist. And even if your page reloads, you'll be able to send this item whenever your application comes back online. So that's kind of how offline request works. If you're using Apollo 1.0 and Apollo offline, mutations kind of handle this for free. You don't need to do too much extra. If you're doing a mutation, it knows to queue that mutation and make sure that sticks around for page reloads and stuff like that. And then you have this update method that you can call when your request actually completes. All right, so we've talked about a whole bunch of areas within the offline world, and I just want to kind of review real quick some of the solutions, and then what I really want to talk about is sort of the recommended tools. This is what I would recommend you use after looking at all of these for each one of these scenarios. So we've got Redux offline status for managing online-offline state. I mentioned the offline plugin, which is super easy for creating service workers if you want to do asset caching for HTML, CSS, JavaScript stuff, even images. If you're looking to cache and persist your data, Redux persist is a really great solution. And then when it comes to query retries and queues, I'm kind of on the fence here, and it kind of depends on your implementation, but I think offline request status can be a really cool way of doing this. Redux sagas are really beautiful. It's also a new package that we just released, so there might be a little bit of a period of making it stable, so if you want to be involved in that, all on board for that. And then there's also Apollo offline, which we mentioned some caveats and stuff. Hopefully those are resolved. But Apollo offline is a really cool solution, assuming that all those bugs and everything have been resolved. Any questions about that? I'm going to grab my water because I forgot it over here. Yeah.
So other than like going to an area where you don't have the internet, how do you like actually simulate intermittent connections in your applications? And where do you how do you do that as a dev?
I don't have a great answer on that. I think the API that we were actually talking about earlier, that I'll mention in a second, is going to be the best way to do it. But really at this point, you're kind of like waiting for like a timeout error. So, yeah.
In Chrome, in the DevTools, you can turn off your connection, and you can also simulate various different connections, like 3G, and you can throttle.
Oh yeah, sorry, for simulations, yeah, you can do that in Chrome DevTools. I thought you were talking about how you'd actually manage it from a dev perspective, or from a code perspective. And that I don't have great answers on yet.
Yeah. Okay.
Yeah.
So one of the things I've seen, I know we had an offline talk last time, and I looked at that, and I tried to kill my network connection on my laptop and load the page, and it wouldn't load until I selected offline inside the browser. So I was wondering if there's anything that I missed that you're supposed to do to actually get it to respond if the network is not available.
Sorry, can you repeat the steps you did again?
So I loaded the page.
Which page did you
This
load?
was, I forget what the page was.
It's like,
I think what probably happened is, so that specifically relies on service workers like you talked about.
Okay.
If you don't have access to the network and you go to a specific URL, the service worker will handle that request and say, we found something for you. You don't even need to go to the network. Now, if you have your Chrome DevTools open, you might have it checked to say, Well, first of all, if you're using Windows,
Nope.
well, so Windows Chrome, it doesn't work, so
No, it's
that
Linux.
API is even worse than he said, like, it's really unfortunate, because even Chrome Windows doesn't work. But most likely, it's a situation where, you can tell Chrome to ignore service workers, essentially, and so therefore, if you're offline, you'd be helpful. We can talk about it afterwards, we don't have to tackle it this time.
But yeah, you basically need a service worker backing everything if you want it to work offline.
Okay. I just wanted to give you a quick tip, because we were using a service worker, we kind of had an inverse problem. We were pushing new versions of our app, and people were just leaving the app on all the time, and it logged out. And we had a conflict because we had like a new version of the app, but their version was compatible.
Yeah.
So like when they tried to, like if they never closed it, then it wouldn't work.
Yeah.
So if you're doing offline first and you have a service worker, and like let's say they've been offline for a day or something, and you push a new version, and then all this stuff happens, but it's incompatible, I'm just letting you know that could possibly
That is an issue.
problem, so I just.
So what he's saying is if you're using a service worker, it's not going to just automatically update. You have to actually have all your windows closed for it to update, or you can actually trigger an update. So one thing you could do is you could have a trigger in your application that says, okay, we just downloaded a new version of this, via the service worker, it knows to do that on its own. Hit this button and refresh. So you might have seen that on like some applications, like Title, for example, uses that, where it just says, hey, it's time to refresh the page. We have like a new version for you. And that's one way you could kind of solve that.
Yeah, that's what it says. Basically says, please refresh. That's
Right.
kind of what we have.
Yeah.
But
But
we
they
also,
still weren't doing it.
Yeah, well, we use a service worker for cache busting, so we didn't want to cache anything for that reason. So that way, we use Webpack to have a new hash every single time. So that way, if we push a new version, it would have to be like, oh, my cache, the hash on the server is not what I have, so I have to get the new version. And you would either do that if you loaded it, or if you had the whole, they just had it open all the time. Because we had no timeouts, we had no logouts.
Yeah.
So.
Yeah, there's still a lot of issues to work out around offline stuff. Like this is still a new concept in the realm of web development in general, but it's so important for our users. So, yeah.
I'm curious about for the queues in particular. Is there any way to invalidate entries in the queue? So I guess I'm thinking like, if you're basically just doing like kind of one big update to your state on your server, and they go out and do a bunch of actions on your app while they're offline, you don't want to have them do 100 web requests all really just updating up to the state.
Yeah, most of those were made maybe when the app was like out of date or something like that. Yeah.
Do they have a concept of invalidation, or basically like even manually the ability to just say flush the queue? I know. That's kind of
I haven't seen a client-side implementation of that. There are some things you can do on the server based on the date that the request was made and stuff like that. But I haven't seen any great implementations of that either. So, yeah.
So you mentioned that your app is used for a Salesforce that may not be connected, right? So what's your approach for handling conflicting updates to the same resource, where you've persisted a local mutation, maybe 30 more, and then you go to retry, and you're mutating an object that has changed out from that?
So our Salesforce application is actually an Android application, so I can't speak as much to that. I think that we're actually not doing a ton of mutations or like patches or anything in that particular application. It's mostly like new orders that are being created, so they're a completely new object. But I don't know, Dan, do you have any answers on that at all?
We don't do anything that special. It just doesn't happen that often, so actually the last entry wins. So if two people modify the phone number of the user, the last one's going to win. We would have a change log of that happening, so if somebody said, hey, that was my lead, my sale, we can go check it out.
Are all of these composable, or are they like independently recommended?
They're independent. Like I don't know how you would even like compose them necessarily, because they kind of all work in different areas, like offline plugins working in your Webpack setup and stuff. So pulling them all together in one area, I mean, you could do that, but what I love about React and the React ecosystem is like you kind of pick the problem for the solution, or pick the solution for the problem. Sometimes we do choose a lot of problems for ourselves as devs. All right, so we can talk more about this afterwards, but I just want to cover sort of some cool things that I think are coming up in the future of the offline world, especially around like Apollo 2.0, and I'm sure you'll be able to add some more to this since you know so much about the cache. But basically, right now, the default implementation of the cache for Apollo 2.0 is called Apollo Cache in Memory. And there's been some discussions already in some of the GitHub issues about how do we make this work offline. And so there's a couple people who want to build this. I'm one of them. But basically like Apollo cache offline that will totally persist Apollo's cache and everything while you're offline. So that I'm hoping is going to come pretty soon. It doesn't seem like it should be that hard to do. There just needs to be sort of some, we need some listeners around Apollo cache in memory to be able to respond to it. And then query retries and queuing. Apollo 2.0, I should mention one of the cool things about Apollo 2.0 in general is that there's a lot more modularization around it. And so a lot of these solutions become easier because you can kind of plug in your own solution. So like it used to be, the cache implementation was a part of the Apollo client. Now you actually have it as a separate package. So that's why you can have something like Apollo Cache offline that you can replace Apollo Cache in memory. But one thing that's cool too is like it has this network middleware concept. So your client can actually have multiple client implementations and multiple implementations for how it handles different connections to the server. And they already have something called retry link. So you can use this to do all of your query retries and handle all your polling and stuff like that in the application. So that's one thing you can kind of play around with now. I haven't done an implementation with it yet, but I think that should be a cool thing to try out. And then as far as queuing goes, there's some talk about building something like Apollo Link offline that will basically manage a queue whenever you make an Apollo request. And again, this is something that hasn't been developed yet, but is already sort of getting some traction. And I linked to the discussion down here that's going on in the GitHub issues for both Apollo Client and Apollo Link. So if you're interested in getting involved in building any of that open source, you should go check that out. And then the really, really, cool feature that's hopefully, I'm hoping these Apollo 2.0 things are like within a couple of months or something like that. But coming a little bit further out, so Network Information API was the thing I was looking for. I haven't looked at the full spec on this, but basically my understanding of it is you're going to be able to tell the difference in data speeds in your connection. So you can differentiate like a 2G speed from a 3G speed from a broadband speed, and then respond to that in your application. So that should be pretty cool. Again, it's not in any browsers yet. It's just an early spec. But once it gets out there, hopefully, go out there and tell Chrome to build it so that we can get it quickly, because I think it is going to be pretty cool. Also, I think there's just a lot of hope for service workers to do way more than we're already doing with them. I mean, the ability to intercept requests is pretty key to offline applications. And there's one really cool thing called background sync, and I think this is only implemented right now in Chrome. But basically what background sync will do is you can sort of wake up the application even if the user isn't using it. And this can be an actual web application. It doesn't have to be a native app. But you can wake up the app or you wake up the service worker when the application isn't being used, and you can say, hey, we're online again. Let's execute our queue now. That way, when the user hops online or hops onto the app again, they're going to have all these queues executed, and they're going to have up-to-date data, and we wouldn't have had to even execute anything when they got going. So that's going to be a pretty cool function, I think, for offline world and also just apps in general. These are a few shout-outs to some cool resources and all the libraries I've basically mentioned in here. Jake Archibald is a really cool guy that does some work on offline. I highly recommend checking out his stuff. He actually works for Google and has done a bunch of Google developer articles and stuff like that on it. And finally, please jump in the open source on this stuff and help building some of the Apollo 2 stuff. And if you're interested, go check out those GitHub issues. And if you have any questions or want to talk to me about any of this stuff, the best way to get at me is on the Denver Dev Slack. I'm at nick.stevens on there. You can hit me up on Twitter. I'm not on there a ton, but I'll definitely respond. And if you need to download the slides, you can hit those there. So that's about all I got. But any more questions before I hand this over to Will?
Does it sound like Apollo 2 is like Meteor?
I never used Meteor, so I can't say.
Everything you basically talked about is, like Meteor 1.6.
Yeah.
sounds like, taking pieces out of it and putting it into Apollo.
Yeah.
Reader was a full stack framework, isn't it?
You might have seen Dax.
It is the same team.
Yeah.
Yeah, of course they need
I do like that I can use React though with Apollo. I mean, I love React, so.
Oh yeah, well you can use React and you can use React in Meteor.
Okay.
It sounds like they're just like pulling stuff out of doing putting it into Apollo.
Modularize everything.
And Apollo server, I mean, if you're using Apollo, if you're using GraphQL, you have to connect to a server.
Great. Cool. Any other questions? Cool. Well, thank you guys so much. Really appreciate it.
Okay, so let's take about 5 minutes to just stretch legs, grab a drink, water, whatever you need. Please stick around for Will Klein's talk on end-to-end testing. It's going to be a doozy. Thanks.
So he it was good to have you. So, see you next month, both of you. I thought about you.
Yeah, I know. I have no
So he's doing all
That's weird.
Where do you live in You've been in some cool cities. Boston, What's your
It's a lot of good migration.
I think that's a good. That was a Windows They finally launched the Windows client. They didn't have one. They said they were working on it. It's still buggy, but hopefully
Now, it's entirely possible because of
I told myself the first time actually sorry about that. I heard about this, I guess, like a year plus ago. It was like, no, I heard about 2 years ago, but I didn't do anything with it because there's a million testing tools. I didn't know the big difference. I'm trying to get on the beta list. I needed to check it out until like it was a viable option. It looked exactly like what I wanted. I'm curious. I think there's a good reason. I think it's a good model. I'm glad there's a team behind it. And then I just, I'm doing an electronic, so I'm like, it's good. It's hard, it's kind of like, even if it's great. It has like weird ass queries.
That's kind of what I feel is that your presentation, this is really decent. This is Bill just came in with this target
Testing.
So yeah, just unmute. There's a top at the top. Just slide that when you're ready.
Testing. Okay.
Yeah. Whoa. I just wanted to listen.
Testing.
Okay, I think we're going to go ahead and get started again. At my job, we do this weird hand-raising thing, where then everybody else raises their hand. It's really weird, but then it like strangely works, because eventually like everybody raises their hand, and it just like, for some reason they get it. The magic happens. We just witnessed it. Okay, awesome. So our next talk is from Mr. Klein here, who is a alumni alumni organizer of ReactJS Denver, one of the OGs. Thanks, Will. So before he starts his talk, that was a good clap. Let's keep going. Before he gets started on his talk, I'm just curious, how many people write tests at their job? Okay, good. Okay, how many people write end-to-end tests? Okay. What is an end-to-end? No, I'm just kidding. So now, how many people use Cypress to write their end-to-end tests? How many people have heard of Cypress? Awesome. Great. All right. Well, I think for those of you who haven't made the jump yet, Will is here to convince you to do that. So let's give him a hand.
Thank you. Does that work? Does everyone hear me? All right, thanks. Okay, cool. So I'm going to talk about end-to-end testing. The game has changed. So we build apps, modern or not otherwise, and a question we often ask ourselves, as Will said earlier, we go home at 4 o'clock. When the build finishes, is it going to work? Hopefully we didn't leave at 4 o'clock with the build still running, but if we did, we hope that we can commit with confidence as developers. We want to know that when we make a change in our application, that we're not going to break the experience for our users. We don't want it to fall apart. So here at the React Meetup, we're often coding in React. Whether we work full stack or not, there's a bunch of stuff in the back end. Between the browser, the back end, the server, the database, external services, microservices, whatever you've got going on, there's a lot that can break down. And you might rely first and foremost on unit tests to have good code coverage, to know that a unit as an individual component does what you intended for it to do. That when you do some refactoring, you make some changes, it continues to work. The real question is, when you put it all together, does it still work? And that's the thing that I see break down quite often, and it's the hardest thing to detect. So one of the solutions to this is to write end-to-end tests. But the question I often end up asking is not, does my app work, but do my tests work? And do they work the way I hope they will? Do they work consistently? Do they work reliably? When there's a failure, do I know that it was the commit that caused it, or there's something flaky about my tests? Or maybe there's something about my infrastructure that broke down. So adding on to that diagram from before, we have our test code. And the thing about this is we have our application between the browser and the back end, but our test code is like its own stack in and of itself. Historically, we've used a tool called Selenium to accomplish end-to-end testing, to drive the browser. And the way Selenium works is, what do I have here? Sorry. So this whole test code thing is kind of implying a bunch of things, because these arrows between the test code and our browser, there's a bunch of things that go on. See, Selenium is written in Java, and we need a few things to make our test code actually talk to the browser. And the first is a Selenium adapter. You can write these tests in Java, you can write them in Ruby, you can write them in JavaScript, hopefully. You can actually write it in any language. I've actually written them in C#, Ruby, and now JavaScript. And had pretty much the same experience in all of them, except if I knew a language better, I had a better time. So usually JavaScript is a good first choice to making this a good experience. But you're still working with Selenium no matter which of these tools you use. And then from there, to speak to the actual browser, whether it's Chrome or Firefox or Edge or IE, as I did maybe 6 years ago, there's a driver specific to that browser that speaks this WebDriver API. See, the way Selenium works is you write your test code, that talks to Selenium, uses its API, and Selenium is essentially a server that just keeps running. And when it executes your test code, it sends commands to the browser. It says, hey, browser, visit this page. Hey, browser, look up the H1 and tell me what the text is. Tell me what the title of the page is. Did it navigate correctly? Okay, I want to log in. Look up the input and start typing in it. Put in a username. Put in the password. Look up the submit button and click submit. Inspect the page again after it's loaded and see if we've logged in successfully. There's a lot of things that could go wrong in that process, but the real crux of the issue is this whole remote API. We're not speaking directly to the browser, we're speaking through like 3 levels of abstraction. Any of one of those can have issues, and the very nature of sending commands to the browser, not knowing where the browser in your app is and its state and how far along it is and what's happening there, you're basically talking to a black box, like with your eyes closed and you're deaf, and you really have very little way of knowing what's actually happening. And thanks. It is kind of funny what we've tried to do all this time. It's very archaic, and it's amazing that it's worked as well as it has up until now, and that's only passingly well. I've spent a good part of the past 6 years trying to work on this and make this better. I actually had on a team, we had a whole quarter's worth of work, 3 months worth of work dedicated to making this experience better for our project. Because these tests, at the end of the day, while they're very costly to write and maintain, they provide a ton of value. You want to know that your app actually works, that the user, from the user's point of view, can click through it, can interact with the browser, and get their job done. Because if you screw that up, they're going to have a bad day, and that's not what we want at all. So I got a little story about a story at work. So I'm consulting with my team at a client here in Denver, and we're building this app that's pretty close to MVP. Our goal right now is actually to get it to MVP. We have a bunch of great developers on it. We have a really strong React code base, really good best practices in place. But we keep introducing bugs. We keep introducing these issues. And these aren't necessarily issues that would be caught by unit tests. They're indeed, they're integration issues. So we've been just suffering through this. And it's gotten to the point where I usually pull code at least once a day, if not multiple times a day. And the best practice has become to wait until you get the thing you want done, because you don't want to break your flow to deal with the issues of the app and not know if it's your code or the app. So we definitely have trouble doing even development with confidence, knowing whether it's something about our work or there's really a regression introduced. So part of the MVP, the client actually made it part of the MVP requirements that we have integration testing. Because at the end of the day, if we've got these issues, we do not want them rolling out to the customer. And our MVP will be absolutely broken if we're committing every hour or multiple times a day with several developers and introducing issues that, frankly, are really hard to catch through manual testing, which is the only way you catch some of these issues. So I meant to put this up earlier. So I had a couple of things to check out. And the first actually was WebDriver.io. I actually gave a talk on that at this meetup a year and a half ago. And at the time, my team was actually working on making that experience better for our whole company. And I was one of the champions of WebDriver.io. And what it is essentially JavaScript bindings for Selenium. So it was that Selenium adapter level. And I thought it was great because we were getting off Ruby at the time. So I wanted to move to JavaScript, write them in a language that we knew really well, and also implement a bunch of test helpers, page objects, over our application to make it easier, as well as creating some libraries to mock out services. One of our challenges was standing up our full stack, which had 1 million microservices, and we wanted to make that easier. So we wanted to be able to just define a route, define a fixture, just mock things out willy-nilly, and off we go. Test our UI, which is what we're really trying to do. And we wanted to run a full end-to-end test. Well, I spent a couple hours with this, and I actually couldn't get a working test on a couple of our input fields. 2 hurdles I ran into was autocomplete. That's where you enter in the street address, and it auto-suggests, it queries like Google and gives you a list of city-state zips. And then you select one, and then it populates the rest. Auto-completes the address. That was one thing I had a little bit of a hiccup with. And the thing I really couldn't get working was our masked fields. So the thing about the masked fields was when you focus into a field and you start typing, certain things were happening where I don't know if it wanted to blur the field or just whatever it was about our application, broke it down because it wanted to mask the field. It got hairy pretty quickly, and I just gave up after 2 hours. And this was using a tool that I had done extensive work on, that I had championed and written utilities on top of. I really had a frustrating experience Nothing had really changed in the past year and a half. The other tool, Cypress. So Cypress is actually something that has been on my radar for a while. The creator of and founder of the company Cypress, Brian Mann, actually gave some talks on it a couple years ago, and he did a bunch of podcasts last year. And so there's been a good amount of material out there. There's a good amount of material out there, and it's all still very relevant. And I would suggest you check them out. But I held off on looking at this for two reasons. First, it was not open source. This was done under private development for some time. That changed in May. The second thing was that it was, well, what was the other thing? Oh, well, there's a company behind it. So it was in private beta for some time. That changed, I think, in October. So very recently. So I was really hesitant to pick up a tool that wasn't open and wasn't something I could just use willy-nilly on something that I wanted at my company, and without trying to ask for an invite. Like, I wanted to know it was something that I could build experience on and take from company to company, and that it would be around, that it wouldn't just shut down in a year and never release the source code because it was bought by something like Oracle. So I took a look at it, and within an hour, I had learned the API, or like 90% of it, which isn't much, or 90% of what you want to do anyway. I had a smoke test through the first several views of our app. I had solved the mask input. I had to do a little bit of work around to write a test helper for that, a page object function for that. I handled the autocomplete pretty quickly. And I was very quickly on my way to introducing this to our project. Right then and there, I messaged Will Beard, and I was like, hey, so that talk I'm going to give next month, I'm going to do it on something else. Because I really wanted to bring this to more people and show it off. So with that said, let me give you a preview, or a demo of something that's actually out there now. So, all right. So let me start with Visual Studio Code. So one thing I found with Cypress is there's like 80 repos on their public GitHub, which is great, including a bunch of examples. So I pulled down their to-do MVC. Sorry, another to-do example. But it's pretty good. It's actually using React, which actually doesn't matter from the point of view of what we're about to do. But inside of this, there's a Cypress directory. There's our application. I'll just show you the package.json real quick in case you're curious. There's a bunch of scripts here for running Cypress in different ways, including with like kind of intended for CI or for actual development purposes. This has got some React going on, and that's about it. So from here, let me dial up some things. So let me run the app so we know what we're dealing with. Oh, do I already have it running? Oops. Wah wah. Oh, it's already running. Okay, I got a Xamarin process somewhere. That's fine. But basically with the to-do, you say, hey, I need to get milk, and I need to get ice cream, and I need to get some sleep. So some things you can do with this is you can like check them off as complete. You can like delete or archive them. You can filter by what's active or completed. You can also select everything and mark them done. So those are some basic things about the to-do MVC. So let me show you what it looks like to actually test this. So I'm going to run Cypress. Now, the first thing that happens is there's this Electron app that loads. So this has got our spec file. I'll show you the spec file in a moment, but let me just run this. So we see our to-do MVC on the right, and we see a bunch of things happening on the left. That's essentially our test runner. It's testing everything in the whole app, making sure it can do everything it wants to. Wait for this to finish. So to give you an idea of what this looks like in the real world, I won't show you the app I'm doing, but there's maybe 24 views that we wanted to walk through. The smoke test for that takes actually about the same amount of time, 30-something seconds. Putting that together and having that just increases our confidence of being able to change something and make sure that we didn't break something in the app a millionfold. We haven't even gotten into edge cases, but some of the other tests we might write is like making sure our autocomplete works on its own, or making sure that some of our branching logic of going through one view or another path through the app, that those different things function. So this is finished running. Let me kind of show you a little bit more about what this test runner will give us. So when I click into this, this is actually, I'll jump to the code in a moment, but there's a bunch of like events that show up here that are actually not necessarily even part of our code. The visit is. This is actually one of our commands. And then there's looking up this element and doing expect to make sure that we have a class on something. But there's this other thing that happens where we see the browser window, the browser location update. And that's what this event is. Question?
Is it possible to make the screen larger?
Oh, yeah. Sorry, that's like super small for you. Thanks. Yeah, is that better? Bad. To give you another example, let's see here. Here's just another quick example. The other thing that, I'm not sure if you noticed, but here's the get on this new to-do input. Here's the type event. Here's the before and after. It's a little hard to see because of the highlighting, but you can actually see the before and after of a lot of these events and really see what's going on with the state of our application. We can inspect our application. This is something that I now take for granted, but this whole view right here of having my test runner on the left, my app in the middle, and if I want to debug either my test code or my application code, it's all right here. So something I glossed over here is that the whole model of how Cypress works is totally different than Selenium. There's no remote service running. There's this remote application running, but then it runs our application in a browser with the test code in the browser, and it loads up this test runner on the side. I actually am really curious about how this all really works and how this time travel stuff works, because we're essentially looking at these DOM snapshots between our events to know what's going on. When there's a failure or when we're trying to write a test and we want to know what we're working with, this is 1,000,000 times easier than Selenium ever was. We don't have to fire up a debugger for our test code and try to get our application to the right state, hope our tests don't time out because they're configured to time out at a certain time, or try to drop debuggers in the right place. We can just run the tests and we can just run our tests and click stop and just start looking at things and poking around and playing with them. We can go in here and just start playing around with what selectors we might want and see if it returns the thing we want. We can execute some of the Cypress commands here and see how they might interact and kind of console drive our development, go back to our editor and be really efficient. I would say that this is as soon as I did this and wrote one test and saw what I could do, right then and there I knew this was the future. And whether it's Cypress a year from now or 2 years from now, and I have pretty good confidence that they're doing a good job, and they're going to continue to do so. But I will say there's other kids in the block, like Test Cafe, that have the same execution model. It's just Cypress has a company around it. They have a team, 5 or 6 developers dedicated to this full time, and they're just hammering on this thing, trying to make this a great experience. And this is absolutely amazing. So let me show you some of the code before I gush any further. So I don't work for, one thing I'll say is I don't work for Cypress. I have no affiliation with them. All the material out there is from Brian Mann and their development team and Gleb, and they work for Cypress. So when you hear them parroting about how awesome it is or how great it is or how well it works, I kind of trust them, but at the same time I don't, because they have a vested interest. I've been working with this stuff, and it actually works. The other thing I'll say, it isn't magically easy or quick to write these tests. There are still issues potentially with your application. I mentioned the input fields with autocomplete and masked fields. Those are just 2 examples of where our application worked a certain way, and I had to do extra work to make that work. But that experience is 1,000,000 times better, and you know what you're dealing with. You know you're dealing with some situation in your application, and often, by the way, that's a smell that there's something about your application that could be better. So let me walk through some of the code. So there's a describe here. This uses Mocha actually under the hood. There's a describe here for everything. before each that every time it visits root, so it reloads the app. And then there's these contexts. These are like nested describes, and this is what gave us, it's actually, where am I going? It's actually here. That's what gives us these drop downs, so we have these like kind of like grouped specs, but it's just like a nested describe. So when the page is initially opened, it goes and looks in and it checks what's focused, looks up what's focused, and then it says that it should have the right class. So yeah, it should focus on the to-do input field. And the other tests are pretty similar. And if you've ever done anything with Selenium, this looks very similar, or WebDriver or anything else. You basically get something on the page, you say it should not exist. You're making sure some things don't exist there yet. You look something up and you type in it, and you hit enter. And then you look up something else to make sure that you entered that item. You look up some label somewhere to make sure that the input field that you entered is now reflected in the list. So while I was writing this, I referred to their docs and had a pretty good experience. They have, frankly, really good docs. I found there's some really great sections on getting started, getting things up and running, how to write your first test. I just walked through those. When you're looking to understand things better, there's some really good core concepts and guides that explain how things actually work, so you understand their model really well. I spent a lot of time inside of, where is it? Their API. Like how do I get something? So I just look for like get here, and it gives me some results here, so I can, actually the first result is get, there's get, and so I can look up the syntax here, see how it works. Really good API docs. I basically spent an hour going back and forth between these docs and my test code and the runner and my app, and just hammering stuff out. It was pretty clean. So I want to show you a couple things about when things break down and what that looks like. Because at the end of the day, you're going to eventually run into a test failure, and that's where things get really cool. So I'm going to check out a couple branches here. Let me check out a JS error. So I just introduced a JavaScript error. I made some change somewhere. It doesn't matter where. If I go back to my test runner and rerun it, let's see what happens. I'm getting a bunch of uncaught reference errors. Props is not defined. So that's my JavaScript error. It's actually showing up here as well. And I've actually had a little bit of an issue with the demo app pulling up the source code. Let's see how well this works. Not that. Sources. So what is this? Props is not defined. Yeah, so one thing I'll say, the stock trace, I don't think it gave it to me. I'm having trouble scrolling, sorry. It gave me the Cypress runner, and then, oh, here's some React stuff, new constructor. Sometimes debugging React or any given application can be a little tricky, but I found a JavaScript error here. Let's say I pull up my source code. Props is not defined when it creates a new to-do. So if I go to to-do item, and I look for props, actually this is it. I don't have this.props here. So that's just one example of a JavaScript error. Let me show you something else. Let me show you a broken feature. So this is just something broken in the app now. I hope. I think it's breaking now. Complete all checkboxes. So let me stop this. Take a look here. Timed out, retrying expected input toggle all not to be checked. So it's actually a little hard to see our app right now. But there's this toggle all button here. And this test tried to, it got the toggle all and checked to see if it was toggled. I think initially it was, I think it checked and then it wasn't checked or something like that. In any case, we can take a look at our code again. See what might be wrong. Oh, not that. Toggle. Well, actually, it's this unchanged. There's a empty handler passed in, so it's not doing anything right now. So that's just another example. show you one more. I'm going to show you some page objects. That looks like. Okay. So over my source code, I've been showing you all these selectors in line. That's not a best practice because this is very brittle. If you change your CSS, say, you change your styles in your app or your HTML markup, you're going to break these tests. And we want to kind of mitigate that. I mean, you can break the test, but you want to make it really easy to update. So one of the best practices is to break things out into a page object. And what a page object is kind of like a test util that knows about your application structure. So I might put the selectors here, and maybe like write util functions like add the to do, because I don't want to just write code that looks up a selector and then types things out manually. I might want to have a function in my code that's just add to do and it passes in some text. So let's see if that worked. Did not. Get to the to-do list, buy some cheese. So here, it put in buy some cheese, but it never, it typed it here. There's the before, there's the after. And then when I tried to get the list item in the list, it didn't find it. So let's debug this. Yeah, that's what I was debug it. So let's see what happened here. So I just threw a debugger into my code. It breaks here. So I can, sorry, this is a little hard to see, but I'm going to narrate. I'm going to step over into my add to do call. And I have seen this work with source maps. I think I did. Right now you can see some transpiled stuff here. And I've done this with ES6 just fine. It supports that without any issues. I think it's based on the version of Chrome that's running, which is pretty good nowadays in terms of support. I'm going to step into this. And here's my add to do function. I get the new to do, and then I type some text. Let's jump over this. And oh man, the application is really hard to see. Let's see. I wish you could sometimes in the debugger, when you're debugging, not blur your window and at least see what's going on. But I know the issue. I'll cheat a little bit here. So if I go to my page object, we're actually missing additional type, and we need to put in enter. Ooh, I think it crashed. Maybe? No, there it is. Okay, sorry. Run that again. Oh, and then debugger. Let's turn that off. Okay. So it's going to run, it's going to work now. Any questions about this? Anything I can show you about how this works?
Is there any, I noticed that all of these are using CSS classes. Is there any mechanism for style components or anything like that?
Thank you. Thank you for mentioning that. So our application has styled components, and all the classes are dynamic, or they might as well not be there, like A and AB, and we're using style, I think. And I ran into this issue right away. So there's a really good best practice that was actually discussed in Topic React and Demo Devs just this past week, which is how can you inject special attributes on the elements you want to essentially instrument for testing. And then how do you strip that out for prod using like a Webpack plugin. So that's actually a really good best practice there. And that's actually something I did in our application is I made some changes to our component code to add these classes and then set up the Webpack plugin to strip them out for production so it doesn't dirty up the markup. I mean, it's not a big deal, but it's just nice to strip them out. I think that's just a really great practice in general, actually, even if you have reliable classes to look things up by. I always kind of had trouble with the idea that my CSS was essentially coupled to my tests. My styles would change, and they might be very minor changes, and my app would just break down. And sometimes that kind of makes sense a little bit. Like if you have good semantic CSS classes, you think they're okay to look things up by, but I just felt like that coupling was unnecessary. So I think it's a really good best practice, whether you're using styled components or not, is to kind of inject that. One neat thing about that is I think you can, depending on how your application is structured, you can do some really neat things like generating a attribute string that like generating a value that kind of has some awareness of where it is in the application. Depending on what you've done with your, what you're passing around in your props, but even if you just have the component type, you can look it up. You can also do things like, if your inputs say have labels, you can look up the label and just traverse over to the sibling input. So you can do things like that too. So you can look things up based on the text in the UI. I kind of like that. It's not really slow or anything like that. You're coupled now to the display text, which sometimes is internationalized, and also the same problems with CSS. But there's no one really great strategy, but pick one. There's usually a way around it. Any other questions? Yeah.
Those DOM stack traces, do you get them when you run in CI, like headless? Can you jump into them off?
Oh yeah. So I haven't tried to do that yet, but I believe so. I'm still putting like kind of the tire to the pavement or pedal to the metal or whatever you want to say about that. I'm still like really putting it in practice. But what I found is that there's a bunch of things recorded. There's screenshots recorded. There's actually a video recorded of this, the whole app playing through. So there's some really good tools for looking up what happened and understanding the state of your application. And if there's something that's not there yet, I think it's only a matter of time before it's implemented. Let me show you a couple other things and wrap up. So here's their homepage. Here's their GitHub. There's a couple examples. This is the example to do MVC. There's a kitchen sink one that shows off some different API stuff. And there's a bunch of things here. They try to like modularize things and open source them as much as possible, which I'm a big fan of. There's a Gitter chat, which is also fantastic. They're super responsive there. There's Lori Lynn's asking some questions and getting some support from the dev team right there. The docs are great, as I showed you. I think I'm really impressed with that. Also, there's some really good podcasts on it. I'm very much a podcast person. I'm actually listening to one of these on the way here. I listened to the JavaScript Airborne and the JavaScript Jabber and the Web Platform podcast. And there's a couple others here that I just discovered today. So if you want to hear the background behind it and what's gone into it, you can hear those stories in the podcast. They're really good. I would definitely check it out. There's also some conference videos, as I mentioned, on YouTube. I want to say, what were they called? But if you look up Brian Mann or Cypress .io on YouTube, you'll find some good results. And even if like what he demos is a little bit dated, his explanation of how it works and why he did it is all still very applicable. Let's jump back to the slide deck. Cool. All right. So it does work. I'm like really happy with what I've had already. Even just having a test that we're running manually that is checked in, that our development team can basically run before when they put up a PR or when they're doing code review, they know that something can work. It's really a million times better to work with than Selenium. Yes. And so what's next? What comes after this? So for me, I'm kind of finishing adoption. I have some more work to do to integrate this with integrate this with our CI. So their model is kind of like freemium. I think it's something like $100 a month for the team to have some premium features and CI stuff. And we're just going to take advantage of it and see how it works. I don't even care if it's like minimally better, because what I've already worked with that's open and free that I can use myself and roll without the premium services, you can get that working with CI with Docker images like yourself just fine. Just take some more effort. I'm happy to, especially to work on a team or to have a client that's willing to pay for good tools, and two, to support the team. I think it's a really good model that they're essentially a business and they're trying to make sure they create value, and they have a revenue model that's going to support the development long term. You see this happen with open source. People just donate their own time. They get burned out. Here's a team that is like, this is their passion and this is their job, and this is their business. And I think they're on the right track with that. And worst case, if they flop for whatever reason, like it's all open source, we can pick it up and carry it. Another thing I want to check out is like look into the source code, see how that time travel DOM snapshot stuff works. That's really interesting. And by the way, I was only really scratching the surface of the capabilities. You can do things like mocking out services and doing like snapshots and potentially visual diffs down the road. I looked at the roadmap. There's some things like that. One of the things I didn't mention is right now it's really limited to Chrome and a couple different versions of Chrome. That was intentional. Supporting all the different browsers and essentially implementing their own drivers was something they didn't want to bite off right away. And I really respect that. So if you're looking for end-to-end testing that checks out all the browsers, if you really need that, you're not going to quite get that here. But I would suggest implementing that in just a more minimal way, using something like Sauce Labs and like WebDriver IO until they have that feature. And it's on the roadmap to eventually get delivered. And I plan to share some more best practices on writing end-to-end tests. There's actually a lot here that I kind of run through, like how do you structure the tests, how you do page objects, how you actually do the development. So I'm planning to write some blog posts and some screencasts and put those up. Something that I actually get a lot of support from my company to do. And check out their podcasts, because there's some really good stuff there. So I think that the game has changed truly with end-to-end testing. It is different than it was 3 years ago. Like, it is a 9-day experience to do what we want to do and to write valuable tests that are a lot more fun to write. Like, I am excited to write end-to-end tests. I can't believe I'm saying that. I would have been shocked to say that like a year ago. And some quick acknowledgments. Thanks to my company, Ecliptic. Part of what we do is getting to come out to meetups and share what we've learned. Work on some great stuff. Brandon Conkle is another speaker that presented here recently. I work with him and a really awesome team. So I had their support putting this together. They helped me with the slide deck and all. And Cypress. The Cypress team has done a really good job with this. It is like the passion really shows that they've put in a lot of effort here to make this better, to scratch their own itch and then to share that with the world. And to get this off the ground is really amazing. There's a ton of code here. Like, there's something like 20,000 commits across all 80 of the repos. And these are like squashed on merge commits too. Like, these are like incremental features. And there's just a ton here to look into. And I think they've done a phenomenal job. So that, thank you very much. I'll leave you with one quote. Don't let your users test your app. That's something I like to say, because if you're not testing these things, that's what you're doing. You're letting your users test your app. You don't have confidence that they're not going to run into a hiccup. This is my daughter going down a snowy slide last week, and I should not let her test that slide on her own. I should have done that for her, because she took a complete butt flop. And she was okay. She's happy. Thank you. Other questions? Feel free to leave if it's late and you want to get
Yeah. First of all, your slides are beautiful.
That was my teammate Gabriel.
Was it?
Yep.
Yeah. Is it, so kind of touching on like what Nick presented on, is it possible to do like offline end-to-end testing, if you will, to ensure the behavior?
Offline end-to-end testing. I don't see why that would be any different. Because if your application works offline, it should just work.
Yeah.
The same. For your test point of view. You can even, you might even be able to push that with Cypress. So you should be able to do that. You should be able to there's a proxy that gets introduced for all the network requests in the browser environment. So you should be able to stop everything. I don't know if that's a lot of effort or not. It's possible.